compilers or something of that nature. What are the tools? Well, there's manual code reviews, and then there's automated tools. There's enhancements to compilers and standard utilities that are out there. The traditional method is, manual code reviews, and we use it in Garrett for it, and it's more than one set of eyes and then voting on and comments that are made on the code that's out there. I have to get a cat picture somewhere along the way too. So enhancements to compilers, you have GCC 8 and 9 and Clang. There's checks that are now showing up, and they're adding more and more checks into the compilers that look for truncating strings using string functions, alignment errors, pointer operations, trying to detect out-of-bound conditions on arrays, format overflows, truncations. Within GCC, or within OpenAFS, there's what they configure, there's an enable checking that basically turns on some of this extra checking. And as things are built, compilers are getting better on reporting the errors. So GCC 9 is now complaining of some errors that weren't showing up in GCC 8. Still kind of blurry, but this is an example of kind of some of the warnings that come out of the compiler. So here you can basically see it's complaining that the output may be truncated between 2 and 11 bytes. So it's trying to look at how some things are being used. It's pointing to areas and format strings that it's helping the developer try to narrow down what is really complaining about. And it gives you some backtracks on some stuff. There you have some standalone utilities, and the utilities I'm going to be talking about are open source and freely available utilities. There are commercial products like Verity is one static analysis package. There's static analysis tools that go into that you can use in IDEs, so as you're actually developing code or working on code, that you get some information right there within the editor. But so Sine has a static analysis analyzer. This is actually kind of it's part of the compiler, but it's standalone utilities, so it kind of fits between. It's part of the Clang, and it's a suite of checkers. It basically has a whole list of things that we'll check for. So basically it looks for core language features and general purpose checks. So it's going to look for are you passing incorrect values or some of that dysfunction, or the standard C element really doesn't like, or something of that nature. It looks for dead code. Is it possible? Is there code in there that you can't reach because of the logic that it's kind of looked at the flow analysis of it, and says you're just not going to get to this block of code. And null dereferencing, so you allocated some memory or you allocated something for this object, and now you're using it. Well, did you test to see whether it's null or not? It's a good example of that. There's security checks that the scan build utility will use, and what that's looking at is are you following certain coding practices that are out there that actually will go out and take a look at some certain programming styles. Are you following certain coding patterns with that? And then it also will look at the Unix and POSIX APIs, so and do some validation of how are you passing the numbers, what are you controlling, what are you using with from there. This is an example of the output of a scan build on the web page. You get a summary of the type of errors that are out here, and then the individual reports. And I'm sorry, I apologize for the resolution on this. But this is an example of a report out of the Sine that a developer can basically see. And what it's telling you in here is basically say, well, assume that I'm taking this branch and assuming that we're going to do this, and eventually gets down to the point, well, assuming these things, here's where the error cost would be. And so that it helps with some of that nature. Another set of errors, this is basically basically pointing out, by the way, this variable may not be initialized at that point. There's a certain code path you could take. Now with this is that you have to maybe take a look at some of these warnings or these errors with a little bit of grain of salt. You may have to say, well, no, it's not going to reach that, that block of code, because you kind of know maybe what the input is or the parameters that may be above and beyond what the compiler or the checkers. Another utility that was used is CPP check. It does some variable checking, out of bounds conditions, appreciated functions, memory leaks, resource leaks, some stylistic and performance errors. And this is an example of what CPP check comes out. And so again, we got a warning that in this particular source code, in this format string, the third parameter of the format requires an unsigned int, but you're passing an assigned int. And here you basically, it's kind of saying, by the way, there's a variable def p that is defined at a certain level within the code, and maybe you can reduce the scope of it, move the definition down into a block so that it's, that just helps, reduce some errors that are out there. This right here, local variable z flag shadows outer variables. So that basically means that somewhere along the line, someone defined z flag at the top level of the function, and then down a bit further, they define it within a block. That can basically result in unpredictable behavior because you may think that you're assigning a value to the outer one, but in reality you're assigning it to the inner variable. Another utility that was used is Facebook came out with a static analyzer called Infer. And there's a bunch of papers that were written up on how it works and stuff of that nature. Null pointer problems, memory leaks, coding conventions, system APIs. Then there's a common theme on a lot of these checkers and what they're looking at, and they do overlap. Some of them have, better strengths than others. For example, the CPP check will actually go out and look at the source code and it will try different variations of the if-ness. So if there's conditional compilation in it, it's going to say, well, let's try it with this one, let's try it with this one. And so it will try the different variations. Some of these other tools basically say, well, this is how you configure the source code for what you're building, that's what we're going to check. And this is an example of the output from Infer. So basically, it's telling you here that there's this one variable, it's a pointer, last assigned at line 7. Could be null, and it's dereferenced at line 98. So it's actually kind of showing you right here. And in fact, right here is the problem, is that there's no test to see if the entry is null or not. So if the CLF fails, then you can have a null pointer. uninitialized value. So let's see, the value read from code was never initialized. So it's basically maybe that value in that particular block of code could possibly be garbage. Infer basically gives you a summary, and this is actually I ran this last night. So this was against the master branch, and this is the number of errors that infer kind of came up with.
Use after free.
What's that?
So use after free.
Yeah.
Look at that.
Probably.
So anyway, so there was some static analysis. There's a static analysis topic in the OpenAFS Garrett, and thank you, Rodney. Hopefully I'm pronouncing his name correctly. He basically ran some analysis and submitted a bunch of patches. And basically what he's finding is memory resource leaks, null pointer references, problems with the printf format strings, boundary conditions, uninitialized variables, and dead code. I mean, that was some stuff that was kind of discovered. There were 19 commits that were underneath that topic. 19 are pending to be merged in, so they need to be reviewed.
25 commit, 19 pen.
Yeah, so 25 commits, 19 pending merge. So there's still 19 of this 25. There's still 19 that need to be fed back into the code base. Again, I apologize. So this is an example of the Garrett. I have a question. How many of you have gone out to the OpenAFS Garrett?
How many are there right now?
So basically, this is as part of the as a code committer, this is part of the process on how code gets into OpenAFS. That it goes through. Someone submits a patch into Garrett. It's basically open for review, and there's a score over here that basically is an indication of the voting process. Because there's 2 of them in here with red, and so that basically means that the review is like some folks basically, not really. Either it needs some changes or there's something with the commit, and that kind of falls back into that that manual static analysis. I mean, this is the process that's kind of with that. One of the things that I would say as a community that's helpful if you understand C code, whatever it is, to contribute to the code reviews, more eyes, better code. So improving the code base, continued code reviews, adding more eyes. Automated tools can't catch everything that's out there. So having more people looking at the code base is always good. The other things is that integrating some of these automated checks into the commit and build processes. There's stuff that's already out there. We can add in some of these other tools and generate reports out there that that can assist on basically flagging some of these errors. That's before it actually gets into the base code and made into the what's executed out and distributed. So, and that's really what I have.
So do we have? So there's a lot of these different tools. Do we have a plan? Like, are there some that we want more urgently than others to be going into the build docs? You have in mind? Because some of them seem more appropriate than others. Like some have like a whole bunch of false positives and stuff. Maybe it's not as appropriate. I don't know if you had an opinion.
I think basically I know that Patrick ran the 3 tools that basically using compilers, scan build, and the CPP check and the infer. I mean, those kind of showed up in his commit comments of the tools that were out there. One thing that we may be able to do is maybe have a step that goes into some of the integration where some of the commits that go out there will run these tools, and maybe just, now I'm just throwing this out as an idea, if maybe sending that be a pen from the build bot saying, hey, this build is maybe have something like, well, we ran a check, we ran these checks one year.
We do nightly build with scan build.
Yeah,
Perfect.
and then making sure that the output of these things are available for use. The infer, the web page one of the infer project actually has some examples of how to integrate this into a continuous integration. So here's the steps you could use to integrate it. So the way that it works, I think it actually will kind of start building up and not rescan the entire thing, but only things that have changed, commits and things of that nature.
So are we working on getting that into the build.org workers? Is somebody doing that?
I would like to see some.
Yeah, no, it's like this slide says we should do this. Is somebody doing this?
Yeah, we have, I mean, scan build's been running for a long time on BuildBot.
Yeah, but some of
But
these,
the other ones have not.
like some of these, I feel like they can be run like per submission, right?
Yeah.
And do they have, so one idea that's, at least some tools have is, so we can't solve all of them, like we can't solve all of them right away.
Right.
And some of them maybe are false positives and it's hard to flag them. So one thing that people do is you just see how many you have now, like you count how many warnings or whatever, and you see if you just see if the new commit creates more.
Yeah.
So I don't know if these tools have built-in support for that, or if we need to kind of write stuff to do
We may have to probably, write that and do a little bit of post processing on some of these. I would probably say that it would probably be something that I would like to see actually happen. Right now, actually, there are two build bots that are running CLang and GCC 8 right now. I'm going to be pumping up to 9.
Is it that's a per submission one or like a daily one?
It's a daily.
Okay.
It's like the barrier for somebody to go and think to look at the daily build logs and then manually do the comparison. Okay, this is what it used to be last time I looked a month or a week ago, and this is what's new. Like that's kind of a pretty high barrier right now.
It's still better than, so, I mean, the problem right now is that somebody does it once every like decade. And so, so we get 25 commits and they're all very long and they're very hard to read through. So doing it, much more incremental would be very helpful.
So yeah, I mean, I think, ideally, we should probably be looking at trying to integrate some of these reports into and pushing it out into the wikis or something like that, where they basically is a little more visible out there. And
We should have Garrett builders that build with warnings for things that we know generate warnings, and then like only look for like the new warning pops up, and they would be able to build.
Yeah.
That's what we should do.
Do you have something like that?
A couple other things. So just like one sort of in general, with this sort of static analysis fixes, our code base is particularly hard to review these changes in. Obviously, there's some for the edge cases in the language or subtle conditions that you need to be looking at when you're doing the review. But this code base has some things in it that were very clever ideas and performance enhancements when they were written 20, 30 years ago.
Things that are wrong that we depend on.
But they are very sort of spooky action at a distance, if you will. And so analyzing the full behavior of the system in the face of them and in the face of these changes can be pretty challenging.
Yeah, that's why there's 19 that are still pending.
Yeah. So, and like, I know, Cheyenne, you apologized that the font was so small. I should be apologizing that there are so many, and you have to make the font small to get them to all fit.
Did you have one?
So, do we use something as sparse for kernel static analysis? So there's something called sparse, the static analysis tool for kernel modules. So you can just run it on your on the OpenAFS.io kernel object wherever we build, and we can see the results. So I just built it and I saw a couple of
What is it check for?
sparse. So the typical errors like null dereference, use after free.
Okay, so it does it on the build code.
So the typical example is that on the user space, let's say you are having malloc and free, but it checks for something specific to kernel like slab and data.
Yeah.
So you can find the bugs on the final set.
Yeah, I don't think anything's been done.
Maybe I can show you that.
Okay.
And the second thing is, I have seen the static tool analysis, they're having some features as incremental analysis, right? So for example, you are having one version of your software.
Mhm.
So you run the static analysis tool, you will get a bunch of false positives. So you mark those false positive. And then when you release the next version, you don't want to see those false positive first of all, and you want to just concentrate on the issues which was introduced incrementally. And these gets integrated with the build system. So let's say you do a compilation, right? And this gets integrated with the build system. During the building, the files get submitted to the static analysis analyzer, and it will give you the report also. So you'll come to know that you have added some new regressions or not.
Yeah, the thing that I thought was always difficult, like that sounds like you flag certain ones that you like ignore, not necessarily ignore, but they're from a previous build, so they're not introduced in this change. But as we move code around so much, that is the identification always accurate for which thing we're ignoring? Because it seems like usually it's line number, so source file line number, but that could be inaccurate.
Right. So typically the way I have used is that, let's say you run it on one baseline code, right? And there are a bunch of false positive, right? So we mark them as a false positive after analyzing them, of course, right? But we want to ignore them, right? We don't want to fix those issues because of some problem. Maybe it will impact some performance and all, right? And then when the developer adds some code, at that time itself it gets integrated with your build environment so that you just get to know what all regressions you have added.
Yeah, but it's not identified just by what line number introduced it. It's maybe the static analyzer, after it does the parsing and everything like that, it has machine readable, it can identify it.
Yeah,
You can detect that they're different.
Yeah, so at least I have seen in Coverity, this thing happens, that it gives you an accurate line number. But I haven't used the CLAN and the scandals. So I'm not sure if those options are available, but Coverity does that.
Well, I mean, in Coverity, I mean, the comment is that there are a lot of static tool analysis tools out there, and some of them are proprietary and cost money, to run. And Coverity is one of them. And
You can get free scans from Coverity.
you can get
Because it's an open source project.
Oh, okay. I stand corrected. And I know that the infer process basically you basically do it incrementally out there. Some of the compiler checks that are currently in there with the enabled checking, I think there is a process right now that you can go in and say, yeah, we're going to ignore this one.
Yeah.
So some of the stuff is already there. It's just trying to pull this together and make it into here it is, for general developer base that's out there. So, any other?
Well, I just wanted to raise the question of, I think, even enable warnings right now is still not on by default. You have to pass the flag in, and maybe sometime you might want to change that, at least for known compilers like GCC, CLang.
Yeah, I should probably change that.
Maybe you could even turn checking on by default for certain specific ones, but that's probably a bad idea. I assume people think that's a bad idea.
I think ultimately it would be a good idea to get to a point where the checks are enabled and builds are failing, with these errors.
Well, so the problem with turning checking on by default is that you get a version of the source, and then there's a new compiler release, and it causes it to break.
Mhm.
So then people turn off the checking, and people get very used to turning off the checking. So you just do it all the time, as a user. So I'm not. I don't know. It sounds like it's a bad idea to me, but I don't know. I wasn't sure. At least warnings could be on. I feel like.
Yeah, I think warnings should be.
We should really do that for the next, like maybe for the next, like the 1.9 series or something like that. I don't know if we need to do that on a major release, or if we can do that in the middle of 1.8 to go.
in the middle. I was noticing some of the examples that you used, and we should fix those for, like the Z flag that was shadowing something. I don't remember seeing that before. Is there a patch for that?
I don't know.
It's in automated code, isn't it? It's in RPC.
It was in RxGen. I don't think it was generated code.
Oh, it's Arch. Okay, I thought it was something that ArcGen was generating, but it's ArcGen itself.
Yeah, like I said, for some of this, I actually ran some of these tools real recently, and I did not pull in Patrick's patches.
Oh, sure.
So it could very well be that some of these are fixed by Patrick's. What I wanted to is I wanted to show what some errors are too. So
Yes, you need the bad code to show the error reports.
Yeah, I really want to see what that views after for this.
Yes.
Get everyone nervous. You did your job. Okay. Any other questions for Cheyenne? Thank you, Cheyenne.